Hello Math 2 students. So we're going to be working on task 2.7 today. So go ahead and get your notebook out. Go ahead and title it the X factor. I'll give you a moment to do that, but do it quickly please. So I'm going to do a fair amount of guiding in the beginning, and I will probably do a couple of questions with you, and then I'm going to jump ahead. You're going to skip over a few questions with me as well, and you'll do a couple of examples with me written down in your notebook, and then you can go back to the questions that we skipped over. Okay? In other words, I'm not going to stay on a video for 45 minutes. We'll do, 10 to 15 minutes, get through some stuff, and then move on, do a little bit more, but you're going to have to go back and fill in the gaps. All right, so here we go. So you got a title, 2.7, the X factor. Let's go ahead and read this. It says, now that Optimus Quilts is accepting orders for rectangular blocks, that's what we did last class, their business is growing by leaps and bounds. Many customers want regular blocks that are bigger than the standard square block on one side. Sometimes they want one side of the block to be the standard length X, with the other side of the block 2 inches bigger. And we know what that means, right? So for number 1, draw and label this block. Write 2 different expressions for the area of the block. And we know how we normally do that. We start with nice function notation, a of x, that's the area. And if you'd like, well, not if you'd like, let's just go ahead and do it. We're going to start with the block that was the x squared already. And they extended one side by 2 inches. But the other side stayed standard. So sometimes they want one side of the block to be standard length. So that's just going to stay x. But up here they're going to extend by 2 units. Now I know from my picture that kind of looks like 2x squareds, but we're really extending this by 2 units, so that means we have a plus 2x at that point. Okay, so at this stage we have 2 expressions to write. You can start with the dimensions on the outside. That would be an x, and some would like to write plus 0, and that's fine. But you can also just write it as x times x plus 2. And the x plus 2 will need to be in parentheses. And we would say x times the quantity x plus 2. Another way of kind of explaining why you can get rid of that parentheses and the 0 is, what does adding 0 do? And I'm hoping you're thinking nothing. Maybe you even said just now nothing, right? So if it does nothing, we can just get rid of it. All right, there we go. So this would be your factored form. Let's go ahead and label that with factored form. And then we want the standard form, which means you can distribute here, or you can just look at your answer down here. X squared plus 2x. And that would be your standard form. So that's basically it for number 1. Let's go ahead and move on to number 2. Sometimes they want blocks with one side that's the standard length x, and one side that is 1 inch less than the standard size. Okay, draw and label this block. Write 2 different expressions for the area of the block. Use your diagram and verify algebraically that the 2 expressions are equivalent. All right, so same concept. We're going to set up an expression here. It said leave one side as x. And then we're supposed to, let's see, have one side 1 inch less than. Now there are 2 different ways to go about this, and I went back and forth in my head and I worked through the lesson myself, and I thought we could try to cut into this because that's one way of describing that. However, I think it gets a little more complicated than we want it to get, so instead we're just going to do this. We're just going to say there's a minus 1 out here. So the original x length, take away 1. It looks like we're adding stuff, but we're adding a negative 1. So as far as the area model goes, we're kind of breaking it down a little bit, but here's what I know. We can still get through this and you guys will understand it probably fairly well. So x times x is x squared still. Negative 1 times x, that's a negative times a positive, is negative 1x, also known as just negative x. So our dimensions, I'm going to drop the plus 0 immediately. There are my dimensions. And then if you were to distribute those, you'll get x squared minus 1x. But we don't typically write the 1. Just like we don't write a 1x squared. It's implied. That means we already know it. If we needed to say it's a different number, we would put the different number. But we are done. This would be your factored form over here. This would be your standard form over here. Now the book doesn't ask you for the forms, but we're heading towards that point where we're going to ask you to change from this form to that form, from this form to that form, and this form to the other 2 forms. So the more we practice that notation or that vocab, the better off we're going to be. All right, so that's it for question 2. I think, let's see, let's take a look at number 3. I can't remember how tough this one was. Let's see here. Let me get that just right so you can read it well. All right, and like we said before, if you'd like to grab your own book, you can do that. At a certain point, you'll need one anyways. So here we go. There are many other size blocks requested, with the side lengths all based on the standard length, x. Draw and label each of the following blocks. Use your diagrams to write 2 equivalent expressions for the area. Verify algebraically that the expressions are equal. So number 3 says one side is 1 inch less than the standard size, and the other side is 2 inches more. So we have a less than over here and more than over here. So over here, are you thinking addition or subtraction? And hopefully you're thinking subtraction. Over here, on the count of 3, tell me addition or subtraction. 1, 2, 3. Yes, that's right, addition. Very good. I'm assuming you responded. All right, so 1 less and 2 more. Here goes. I'm going to go put this one over here on the right side, see if I can save a little bit of space. Let me start with the diagram first this time. So I'm going to go x squared here. There's my usual. There's the x. And it said reduce by 1. So we could go maybe minus 1 on this side. And then increase by 2. So we'll go plus 2 on this side. And let's go ahead and finish it up. So we've got 2 of the x bars over here, a negative 1 x bar over there, and now this is different. What's going to be down here in this bottom little box? First thing I would ask you is how many boxes are there, and you should say 2. Now should it be a positive or a negative 2? And now we get down to the idea of its multiplication. So we went x times x times negative 1, x times 2, and 2 times negative 1. So I'm hoping you're thinking negative 2. So here goes. Area of x. Let's go dimensions first. X minus 1 times the quantity x plus 2. And then what we're going to do is pull these out. And then when you can combine like terms, of course, we do. So we have an x squared, and then these 2 guys right here. We've been combining like terms for a while now. Are there more negatives or positives? Positives. By how many? Yes, 1. And we'll leave that as a lurking 1. Like, we don't need to write the 1 there, but if we needed to, we could shine the light on it and have it come out of the shadows. So there we have our factored form here and our standard form here. This is kind of an in-between form. We don't really have a name for this. So that's that. That would be your number 3. All right. So let me see here. Let me see what's next on the docket. I believe the next few you guys will be doing on your own. So that being said, you're going to be doing a 4 and a 5 and a 6 and a 7. And then, let's see, I believe there's a number 9 that we want to start talking about together. Let's see here. Let's take a look at the directions here. Make sure everybody's clear what they're asking for. So one side's 2 less than the standard, the other's 3 inches more. Hopefully that is ringing a bell. That sounds familiar. We did something similar just a moment ago. 2 more than, and 3 less than, 3 more than, 4 less than, 4 more than, 3 less than. So they're using some of the same numbers, but kind of moving things back and forth so you can see how it adjusts your final answers. All right. So at this point, I think what we're going to have you do is jump ahead to number, let's see, I lost it. Number 12, I just need to point out there's a typo. When you get to number 12, they said the right thing up here. It says some customers want both sides of the block reduced, which means subtract and subtract. But then for part B, they left it as an add and a subtract. So I'd like you to change that one. When you get to 12B, just make a note of that. Okay, that there's supposed to be x minus 1 there and x minus 4 there. And it has draw the diagram for the following blocks and find a trinomial expression. Trinomial means you already have factored form, so we're looking for standard form. And it says use algebra to verify the trinomial expression that you found from the diagram. So diagram, and also you're going to give me a trinomial in standard form. Okay. The other questions, 10, I don't need to explain. I'm going to have you guys just do that on your own. And I would like to jump up to number 14. And this is actually the end of the task, believe it or not. You got, a fair amount of things to answer in the process, but at this point, it says number 14, Optimus Quilt Shop has received a number of orders that are given as rectangular areas using a trinomial expression. So that's your standard form. Find the equivalent expression that shows the lengths of the two sides of the rectangles. In other words, we would like factored form, or the dimensions. So we've done this before, and it was always positives, but now they're mixing in, after part A, they're mixing in some negatives, more negatives, one negative, one negative, one negative, and some negatives in a weird spot. So what I would like to do is maybe do as a sample a 14b. And you could put this anywhere on your task. You could do it right after what you just finished. That's where I'm going to put it. I'm going to take x squared plus 3x minus 18, and we'll do that one right now. This is 14b. They gave us x squared plus 3x minus 18. Now, if you remember what we did last class, we kept talking about how you're going to be multiplying to get this thing out here and adding to get this thing out here. Some of you even use a little diamond to keep track of that. So I'm going to go ahead and put the diamond on here. We need some factors or numbers that multiply to get the negative 18, but they add to get a 3. So you don't need to draw the diamond for me, but it's a nice little technique to kind of keep track of things. I also like to go make a list of factors that multiply to get negative 18. So I'm going to do that right here. I think I can squeeze it in. And I like to organize it like this. I just write down the number that we're multiplying to get, and that because it's a negative, we're going to go negative 1 times something. So the something would be 18 in this case. And while you're doing this, you're searching for a pair of numbers that not only multiply to get the negative 18, but they also add to get the positive 3. And there's no way that's going to happen, so we'll go negative 2. Does negative 2 go into negative 18? So negative times a positive, of course, to get a negative, and that would be a 9. But what do those numbers add up to? That would be a 7, not a 3. Okay, so let's keep going. Does 3 go into 18? And the answer is yes. It would be 6 times. And of course, one of each sign. And then you can keep going on this list. 4 does not go in, 5 does not go in, 6 goes in, so you could go negative 6 times 3. And if you haven't found your answers already, you just keep on making your list. Some people like to make the entire list first. I don't like to make the entire list first. I like to check my list as I go. But I do go in systematic order. I'm going to try to put a 1 in, then a 2 in, then a 3 in. Try a 4. If it doesn't work, try a 5. I'm not going to jump around. Because if I jump around and just pick random numbers that come to the top of my head, I might be missing some factors. So you'll notice right here, negative 3 plus 6. Those add up to a positive 3. So here's what we just figured out. If I were to rewrite this as x squared minus 3x plus 6x minus 18, these two terms right here in the middle will add up to the 3x. In fact, that's going to tell us the dimensions here in just a second. What you could do at this point is draw a little diagram to go with it. I did say could. That means you do not have to. If you don't need to, I don't need you to. Okay? If you would like to draw a diagram, go ahead on 14. But I don't need you to for me. So for sure, we're going to have x times x. That's this part. Now, it looks like we need a negative 18, so we're going to have to go negative times a positive. And we've already figured out it should be a negative 3, so I'll go like maybe, let me go 6 this way. That way I don't have to go far down here. We'll go 3 this way. So that's going to be a minus 3 down there. And then we'll have a plus 6 out here. All right, so then from there, you're going to see we have a negative 3x over there. If you want to split those up, you can. You don't have to split these up anymore. I think most of you see that there are 6x bars there. If you add a 6x and a negative 3x, you get your 3x. Most important thing is you are going to get 6 times negative 3 is negative 18, and you can see the dimensions at this point. Now, that's a lot of work, much of which you do not have to do. Okay, if you can see it right away, you can go straight from here to here to here. I forgot to fill in my diamond. I got so excited over here, but usually you go put the numbers here and here. But again, you don't need a diamond for me. You just have to know that you're trying to find numbers that multiply to get the negative 18 and they add to get the 3. Something else you can do, I'm going to just put an or right here. Please add this to your paper. Just go ahead and make your general Punnett square. In fact, it doesn't even have to line up with the boxes on your graph paper. You're going to go like this, x times x, you're going to get an x squared. We definitely need a plus something and a minus something. So now I need the numbers that multiply to get negative 18. I know this for sure. So you're going through your list and you're finding out that, oh yeah, it should be a negative 3 and a positive 6. And then you can just throw the 6 times x in here and the negative 3 times x in here. We do not need the physical model to match perfectly with the number of boxes. We can just use the Punnett square idea, where it's just kind of 4 squares or rectangular looking things or messy looking things. As long as they're keeping track of the information that you need and they can get you the answer, we are good to go. All right, so that is your 14B. You have quite a few more of those to go through. Your homework today is going to be the Ready, Set, Goes, but I did you a favor and I put them onto a handout so you can get that from the substitute when you're done with the task. Let's make sure you finish the task first. Okay. What I'd like to do though is I'm going to show you how to do a little bit of the Ready, Set, Goes, but not right this moment. I'm going to go ahead and just stop right here. For this video, I'll make a second video that kind of explains a little bit of the Ready, Set, Goes. It'll be a short video, but at that point, we'll have you guys have the handout in your hands. All right, we'll see you in a little bit. Thanks.